Dear students, as per the syllabus, we will go with the calculation of no load loss and no load power factor of a single phase transformer. The theoretical part will be taught in the theory part, the theory classes, and the experiment part we are going to thorough about this one. This is the one experiment of basic electrical engineering. We have to find out what are the apparatus we need. Well, obviously, this is a transformer test, no load test. So we need a single phase transformer. Ratings are given: 1 voltmeter for measurement of voltage, ammeter for current, and obviously one single phase wattmeter for measurement of power. Variac we need to vary the voltage, AC voltage, as we can't connect with the higher range of voltage, and some connecting wires we need for the connection purpose. This is the circuit diagram. We need to connect the circuit. Before that, I want to go through about some theoretical part that what we need to measure on. Here, as you know, there are two types of components. One will be working component, another will be magnetizing component in this open circuit test or no load test. That IW will be I0 cos phi 0. So we have to find out the I0 value here and the power factor value from this experiment. So we can find out IW. Similarly, we have to find out magnetizing component, that is I0 sin phi 0. So if we got I0 and if got the phi value, then obviously I can get the magnetizing component. Similarly, we have to what was our M? M was to find out the core loss, that is core loss of resistance, that is R0. We know R is equal to V by I. According to phasor diagram of the single phase transformer, R0 is equal to V1 by IW, which you have already studied in the theoretical part. That magnetizing reactance or magnetizing component X0 is V1 by Im, that is I mu. Also in some books it's mentioned that is I mu. And total power, that is P is equal to V I cos phi. Here we have mentioning as it's a wattmeter, that is OW, and V1 why, because it's the supply voltage, and I0 because it's open circuit test, then cos phi 0. And this is all about the wattmeter reading. And this is the circuit diagram which we are going to do the experiment. Here first we have to put a single phase supply, then a variac, positive negative. Positive is connected to voltmeter positive, then voltmeter positive is connected to M point of wattmeter. Then as you know, MC always we have to short circuit, as there are two types of coils, one is current coil and another is pressure coil. MC will be short circuited. L point of wattmeter will be connected to ammeter positive side, and ammeter negative side will be connected to the LV side, low voltage side of the single phase transformer. And another terminal, the second terminal of the LV side of the single phase transformer will be connected to wattmeter V point, that is here we are considering 300 volt as per the apparatus required, as per the ranges. Then wattmeter V point will be connected to voltmeter negative, that is 300 volt. It is written mentioned here, and voltmeter negative will be connected to variac negative. That's all about the theoretical circuit diagram. This is the observation table which will find out. First we have to find out the ammeter reading from the experiment. We will do this after this study. Then voltmeter reading, what is the voltage we are providing from the supply, and wattmeter reading from the wattmeter we have to measure here. We can take 2 or 3 observations for our betterment or better efficiency. Then we have to find out cos phi, R0, X0. All the formulas were I have discussed before. Cos phi is equal to W1 by V1 I0. I0 given, V1 given, W. All the parameters we have already calculated, we have already find out. From there we can find out similarly cos phi, R0, X0. This IW, R0 is equal to V1 by IW. IW I told it will be I0 cos phi 0. Here you can calculate from the observation table. Now let's move to the practical part. This is the variac one. We have connected the variac positive side, which any part you can consider it positive. I have, as per the circuit diagram, this will be connected to M point. MC will be short circuited. I already discussed. MC will be short circuited. Then from M point you have to connect the voltmeter positive. Here it's connected. Then the voltmeter negative will be connected to the voltmeter negative, that is 300 volt, will be connected to the wattmeter. negative side. Then wattmeter negative will be connected to the transformer. Here it is a transformer secondary winding, sorry, primary winding. Secondary winding kept open because it's open circuit test. And another point, another terminal of the transformer I told already will be connected to the ammeter negative side, that is 1 ampere. We have connected, this is 1 ampere. Then the left part, the second terminal of the variac will be connected to voltmeter negative point, that is 300 volt. This is all about the connection. Let's start the experiment. Let me switch on the supply voltage. Just for a reminder, we need to, precaution purpose, we need to start it from the zero. If we start it at any working voltage, then it may hamper the load part. So we will put it at 0, then we will switch it on. Now we make it switch on. Light is blowing. Now let me rotate this one up to some range of voltage. Let me move it up to 110 volt. 110 volt. So in this, suppose 115 volt. As I have a reference value, so I put it 115 volt. Then I have to find out the current ammeter rating. This is the ammeter rating. You can see 1 ampere I have connected to lower range, lower calibration, that is 0.4. So I have to write here 0.4. Previously it was 0.315. It may vary according to the different situations. And wattmeter reading, here you can go with each point is, each mark is 5. Yes, it's 5. So the pointer is on second point, so that is 10. The wattmeter reading is 10. Here it is 18.4, but here we have 10. According, after that we have to go with the calculation. We have to find out the cos phi, R0, X0, and here it is IW, I mu. After that we have to move the conclusion part, and some questions are there. In conclusion, we have to write from this experiment, we find out the no load loss of power factor, no load loss and power factor of the single phase transformer. This is all about the experiment number 4. Thank you.